Hey guys, welcome to video 3, converting polar to rectangular. So we have this image here, and what we're saying is, let's say we have a polar coordinate. Like, let's say we know this is a 30-degree angle, and we know this distance r is 6. That would give us a polar coordinate of something like 6 comma 30 degrees. But what we want to do in this lecture is decide, well, what would that be x comma y? Because remember, this point is 6 comma 30 degrees, but it could also be represented as some x and some y value. So we have to come up with a way to do that. And what we're going to do is we need to think about the relationship we have in this triangle here. There's a couple of things that we've known for a while. Most notably is SOHCAHTOA, stuff like that. That's very, very basic trigonometry we've known for a few years, but we can use that in this case. For example, this is supposed to be a comma right here, by the way, x comma y, not x point y. So let's look at cosine first, and I think you'll know why in a minute. Cosine of theta would equal, well, cosine, if you think back to SOHCAHTOA, that's your adjacent over hypotenuse. And adjacent angle theta here is x, and your hypotenuse we're labeling as r. So forget about the 6 comma 30. We'll get to that in an example when we get to the converting problems. Right now, let's just focus on using x, y, r, and theta. So cosine theta equals x over r. But what we can do is we could rearrange this equation so that it's solved for x. And what you could do is you could simply put this over 1, cross multiply, and you're going to end up with x times 1 is just x equals r times cos theta. We're going to write as r cos theta. And that's going to be our equation to find x from r and theta. So if you have 6 and 30 degrees, you could find x by doing 6 cos 30. And that's why I started with cosine, is because it involves the x value. Remember, cosine is x and sine is y. So now let me switch over to sine, and we know that sine theta is opposite over adjacent, that is y over r. Right, here's our opposite angle theta is y, and our hypotenuse is r. And so when I cross multiply this, I get the equation y equals r sine theta. And these are the two equations we're going to use. X equals r cos theta, y equals r sine theta. And so if we have r and theta, which we do in a polar coordinate right here, then we can simply plug into these two equations to find the x and y values. And so that's what we're going to do, and we're going to use our calculator to help us out. Make sure your calculator mode is set to degrees. Just give me 1 second. Make sure my calculator mode is set properly to degrees, and it's not, so it's a good thing I checked that. I'm going to put my calculator on degrees, get out of there, and so that's ready to go. All right, so our first example, 6 comma 30 degrees. I have 3 things I'd like you to do for these. I'd like you to first state what quadrant it's in. And so we're going to examine this, like if we were to plot this on a polar grid. 30 degrees we know is quadrant 1. And that's basically what we're going to do, is we're going to use the angle to determine the quadrant. But you have to be careful, because remember, when this number is negative, you actually end up in the opposite quadrant. So because it's positive, we could just trust that angle 30 means quadrant 1. And so we're in quadrant 1. And let me actually write that next to this. So quadrant 1, capital Roman numeral I stands for quadrant 1. And the conversion process is going to use these two formulas we just created. X equals r cos theta, y equals r sine theta. So we're going to change this to 6 cos 30, because that's your r cos theta. Remember, this is r and theta. And 6 sine 30. Okay, and so I want to type these in one at a time. So if I type in 6 cos theta, 6 cos 30, 6 cos 30, I end up with a decimal that is really not very recognizable. So what you need to do in that case is you need to just focus on it piece by piece. I know this is a 6, and I know it's times cos 30. Now 6 cos 30 I won't recognize in my calculator, but regular cos 30 I should. So I just do regular cos 30, and maybe this is one you have memorized. The 0.866, we know that really is radical 3 divided by 2. 6 sine 30. Sine 30 is 1/2, and I could type that into my calculator, and I'll get my 0.5. All right, sine 30. Sine 30 is a half. So it's 6 times rad 3 over 2, and it's 6 times 1/2. 6 times rad 3 over 2, you're going to see a lot of shortcut. What you could do is simplify when you have these fractions that this is, instead of 6 times rad 3 over 2, I could reduce the 6 and the 2 here. So that's really 6 divided by 2 is 3. 3 times rad 3 is 3 rad 3. And you divide by 2 here and get 3. 3 times 1 is 3. That is my answer. That's my x comma y answer for 630 degrees as polar. This is my rectangular coordinate, 3 rad 3 comma 3. And so that's my conversion process. I stated it was quadrant 1. How do I confirm it's quadrant 1? Well, the way to confirm it's quadrant 1 is simply thinking about in our quadrants. We know in quadrant 1 x and y are both positive, but in quadrant 2 we're going to have a negative x, y. In quadrant 3 it's going to be negative x and negative y. And in quadrant 4 it's going to be positive x, negative y. So the fact that I see I have 2 positives here for x and y, I know I'm in quadrant 1, so it's confirmed. Let's look at another example. So here's number 2. 2 comma 120 degrees. I want to change it to 2 cos 120 comma 2 sine 120. Just like that. And I'm really going to turn that into 2 times whatever cos 120 is and 2 times whatever sine 120 is. And I'm going to get those from my calculator. And they can be recognizable decimals. So cos 120 is negative 1/2, and sine 120 is our 0.866, and it's positive. So negative 1/2 and positive rad 3 over 2. Also, I forgot to state my quadrant. This is quadrant 2, and I see that because my angle is in quadrant 2, and my R value is positive, so I know I'm in quadrant 2 with 120. All right, so a little bit of algebra here. I could divide these, and they pretty much cancel out. I get negative 1. Divide these, they cancel out, and I get radical 3. So negative 1 comma rad 3. Is that in quadrant 2? Well, it's got a negative x, positive y, so absolutely it is. That's confirmed. Example number 3. Negative 5 cos 300 and negative 5 sine 300. It's going to be negative 5 times whatever cos 300 is and negative 5 times whatever sine 300 is. So let me find out those values. Cos 300 is a half. Sine 300 is negative 0.866, so that's going to be a negative radical 3 over 2. All right, in this case, I can't simplify, like I can't reduce 5 into 2, so I can't cross those out, and so all I can really do is do negative 5 times 1 on top divided by 2. And this is, first of all, a negative times a negative, so that's going to cancel each other out to be positive, but it's going to be 5 times rad 3 is 5 rad 3 over 2. And just like in the last example, I forgot to do step A. So what quadrant are we in? And this one's actually a little tricky because this 300 makes you think you're in quadrant 4. However, we're not. Because, remember, when R is negative, you end up in the opposite quadrant. So if I think I'm in quadrant 4, that negative R makes me shoot over and actually end up in quadrant 2. So this is really in quadrant 2, which is confirmed by having a negative x, positive y. So the quadrants are really helpful for confirming your answer, but you got to make sure that you got the first quadrant correctly, stating the quadrant to begin with. And I really should have started the problem with that. But it's okay that I kind of went back and let me check the quadrant of my polar and rectangular and see if they match up. That's really the same thing. Um, but, what quadrant is your rectangular? And that's simple. It's just x and y. Is it positive x or positive y and so on? Using this, you can determine your quadrant. But determine the quadrant of the polar, it's easy when r is positive, but when r is negative, you got to be careful with that. It's not just, it's the opposite quadrant as your angle, and so that can be a little tricky. And one more real quick one. I know we're all almost at about the 10-minute mark, and that's where I like to keep it, but I want to do one of these real quick. What quadrant is 270 in? Well, it's actually not in a quadrant. It's quadrantal. It's between quadrants 2 and 3. And so it's on the x-axis, right? It's on the y-axis. Here's your 270 mark. And so 4 cos 270, comma, 4 sine 270. And that would be 4 times cos 270 and 4 times sine 270. So let me just calculate these real quick. 4 cos 270 is 0, and, oh, I did 4 cos 270. I could have just checked 270, but cos 270 is 0, so 4 times cos 270 is 0. And sine 270 is negative 1. So cos 270 is 0, sine 270 is negative 1. And maybe you remember that because at the quadrantals, remember it's the coordinate. This would be the coordinate 0, comma, negative 1 on the unit circle, where this is cosine and this is sine. But your calculator will always tell you. 4 times 0 is 0. 4 times negative 1 is negative 4. Are we between quadrants 2 and 3? Absolutely we are. So we know we're confirmed and we're good to go. All right, see ya.